Okay, we're going to look at problem 951. It says the truss is made from 5 members, 1, 2, 3, 4, 5, each having a length of 4 meters and a mass of 7 kilograms per meter. If the mass of the gusset plates at the joints and the thickness of the members can be neglected, determine the distance d to where the hoisting cable must be attached so that the truss does not rotate when it is lifted. Okay, so immediately, if you've been watching these videos, if you attended the classes, you will see that you should have noticed by now that what? Sorry, I don't have the most amazing studio, so I need to shift things around. Okay, so what you noticed is doesn't matter what kind of structure you have, doesn't matter what it looks like, if you can locate the center of gravity, which is the center of mass, right, or the centroid. If you, we know that that point is where all the weight is acting. So if you can perfectly oppose that force, then there will be equilibrium, right? Rotational equilibrium. Okay? So if you go and apply that force there, for example, then you know that there'll be a moment, right? But if you apply the force exactly opposite the center of gravity, then you're going to have rotational equilibrium, meaning the sum of the moments equals 0. There'll be no rotation, okay? So that's essentially what this is saying. It's got this problem 951, right? It looks something like this. It's got these members, right? It's a truss and it's got these members. And each member is 4 meters long, okay? And we've got some angles here. And it's essentially saying, right, where can we apply this, this hoist so that the truss does not rotate when it's lifted? Well, the only place you can apply that is if you're applying it directly above the center of gravity, right? The center of mass, even the centroid. Okay, I hope that's clear. So what do? Well, we have to divide it into segments. Okay, so we divide it into segments. Number 1. Number 2, we calculate the length of each one. We need to calculate the x tilde and the y tilde of each one. We have to calculate the x tilde and the length, the y tilde times length of each one. And then we need to apply the sum, we need to apply x bar is equal to the sum of xi li over the sum of the total length. And we need to apply y is equal to the sum of the yi li over the sum of all the lengths, okay? So why do we want all this? Because we're trying to find the x and the y. So if we can find the location of the center of gravity, then we know that we can apply the hoist right above there and it will not rotate because the location of this force passes through the center of gravity. Because the center of gravity is acting down there, we want to find this x bar and y bar. That's what we're looking for. We're looking for the location of the center of gravity. Okay, so let's put our x there, put our y there, and now we need to analyze each of the members. Okay, so let's set up a table. Say segment. Remember, we're not working with areas, we're working with lengths now. So we go length. Before, in the previous example, we had areas, so we just replaced that with area. You could have a problem with weights, you could have a problem with masses, you just need to replace that, right? So the length of each segment, then what is the next thing that we could possibly want? We would want the x tilde, we want the y tilde, so this is the location of the centroid of each individual element or segment. Then we need x tilde times L, and we need y tilde times L. Okay, and we can have 1, 2, 3, 4, 5 members. So 1, 2, 3, 4, 5. Okay, So we just set up our table like that. Set it up. Okay, so let's call this 1. Let's call this element 2, that 3, that 4, and this one 5. Okay? So this takes just a little bit of thinking, but it's really not difficult. So we know that the length of each one is 4, so we can just put that in. Okay, 1 mark in the test. Okay, not much thought involved with that. So let's have a look just at that element. So what would be the x tilde? So the location of the centroid. We know that the centroid is there. That's where the centroid is of that beam. Okay, so if the total length is 4, if the total length of this is 4, okay, how about I draw it over here? The total length of this beam is 4, but the centroid is located there. So I know if the total length is 4, then the location of that, if I go in that direction, is 2. Okay, are you still with me? I hope so. But we know that that angle there is 60 degrees. Okay, and I'm looking for that length there. That's my x tilde. That's my x tilde. So I need to go 2 cos 60 would give me that x length. Okay, so I hope you got that. 2 cos 60 gives me 1. Magical number. And then if I want the vertical length, which is my y tilde, it is 2 sine 60, which is 1,732. Okay? Then if I multiply that by that, I get x times L, I get 4, and that 4 times 1.732 gives me 6,928. Okay? So now what's the second one? There's my the second member. We know that the length is 4, the x will be 2, and what about the y? It will be 0, because it's not going anywhere in the y direction. Okay, so 4 times 2 to get that gives me 8, and that is 0. Okay, what about this element here? We know the length is 4, and we know that the location of the centroid is there. So how do I locate that point in terms of x and y? Well, I know that the distance from there to that vertex there will be 2. I know that. Okay, don't look at my terrible drawing, but I know that that vertex there gives me 2, and then I've still got to find that distance from that point to the centroid, and I know again that that'll be 2 cos 60 to give me that distance there. Okay, so it's going to be 2 plus 2 cos 60, which is that horizontal distance. So it's 2 cos 60 plus 2 is 3. So that's my x tilde for segment 3. Okay, my y tilde is just simply going to be the same as the y tilde for that one, which is going to be 1,732. Okay, so if we multiply 4 times 3, we get 12, and 4 times 1.732. Oh, okay. I should just read. It's the same, 6,928. Okay, so we've done these 3 now. Now we need to do that element there. Okay, so what is the length? It's 4. What is the x tilde? It's going to be 2, because that's that point there is 2, plus 2, because that's the location of the centroid, right? So 2 plus 2, 4. Okay, and the height is simply going to be what? It is going to be 4 sine 60. It's going to be that height, which is 4 sine 60. 4 sine 60 is 3,46. Okay, so that's the height of that centroid there for that element. And if we multiply everything out, we get 16 there, and we get 4 times 3,46, which is 13,84. Okay, now we just have this final one, which is element 5, and we know that the centroid is there. We know that the length is 4, and we need to locate that position in terms of x and in terms of y. So x will be, we will add up that 4, that's 4 plus 2, because that's 2, and we need that distance, which is 2 cos 60. Okay, so 4 plus 2 cos 60, we know 2 cos 60 is 1. 2 cos 60 equals 1 plus 4 equals 5. So the x location of that centroid is 5. Okay, the y location again will be the same as this, 1,732. So if we multiply, that becomes 20, and that becomes again 6,928. Okay, so now based on these equations, I need to get the total length, and I need to get the total XL and the total YL. Okay, so what do we have here? 4 plus 8 plus 12 plus 16 plus 20 gives us 60 here, and we have 6,928 times 3 plus 13,84 gives us 34,62. Okay, I really hope I'm right. And 4 times 5 is 20. Okay, 4. Okay, I know this is a very simple, I don't want to make a mistake there. That's 20, obviously, right? Okay, so what is our x bar? It's equal to 60. Let me get that there. 60 over the total, which is 20. 6 divided by 20 is 3. Okay. And then what is the y bar? It is going to be this divided by that, which is 34,62 over 20. 34,62 divided by 20 is 1,73 meters. Okay, so when we look at our structure, we need to apply this hoist, right, at a distance of 3 meters. Okay, from this point over there. Okay, and the y bar is 1,73. But the question is not over. It says if the mass of the gusset plates can be neglected, truss is made from 5 members. Let me just have a look quickly. Hold on 1 second. Okay, well, I've actually solved the problem. I just looked at the solution now in the textbook, and they use, instead of XL, they use X times the mass over the sum of the masses, right? They use Y times mass over the sum of the masses. Okay, so it's really exactly the same thing. All they did was they multiplied this length by the 7 kilogram per meter. Okay, so there is really no difference. So all they did was they said the mass is equal to it's equal to the total length times the mass per length, right? So that's all they did was they substituted in there, and they got exactly the same answer. And actually, I answered too much here. I also calculated the y bar when all we actually needed was the x bar, which is 3 meters, right? That's what they wanted. But hopefully it helps you just understand how to calculate the centroid both in the x bar, in the x direction, and in the y direction. Okay, guys, so the point is, if we apply the hoist at 3 meters, then there will be no rotation, no effective moment, because the total weight is acting down at that point, and we need to oppose it there and lift it up so that there's no rotation. Okay, hope that helps. Cheers.